Girls, today we're going to learn about Unit 2, linear relationships, but we're moving on to Chapter 4, equations of linear functions. This is going to be very similar to what we did in Chapter 3, where we also learned how to write some equations of linear functions, but now we're going to learn a new formula called point-slope formula. This is going to help us with goal 1, which is to write the equation of a line when we're given the slope and a point on the line. The point-slope formula for a linear equation comes from the slope formula. So let's first remember the slope formula is m equals y2 minus y1 over x2 minus x1. In order to get point-slope form, what we need to do is get rid of this fraction. So rather than having y2 minus y1 over x2 minus x1, what we're going to do is we're going to multiply both sides by x2 minus x1. So that's going to look like this. When we multiply both sides by x2 minus x1, let me move this over here. It's going to cancel out on the right side. So we would have x2 minus x1 multiplied by the slope equals y2 minus y1. Now, we're only going to have one point that's given to us, and we have to keep the variables x and y. So instead of using x2, we're just going to put x minus x1 multiplied by the slope equals y minus y1. So instead of the second point, we're just going to use the variable x and y. Now, this is a good equation, but it's just not how you're typically going to see it written. You're going to typically see the y's on the left-hand side and the x's on the right-hand side. So we're just going to switch this around to say instead y minus y1, we're just going to put that on the left, equals, and then we're going to put slope multiplied in the front multiplied by x minus x1. So I'm just switching the two sides to come up with my final form for point-slope form. You need to highlight that in a bright color because it's extremely important. You'll have to memorize it. It's called the point-slope form for a linear equation. So when you get a question like example 2 where it says write an equation in point-slope form, when it says in point-slope form, that should be the key to tell you to use that equation we just wrote. It's telling you the point that it passes through, 3, negative 2, so that's our x1 and our y1, and it's telling you the slope of 1/4. Remember, m stands for slope. So the first thing you'll do is write down your point-slope form. Y minus y1 equals m times x minus x1. Take your given information, x1, y1, and m, and substitute it into your equation. So you're going to have y minus, and then you'll substitute in negative 2 for y1. Remember, anytime you substitute a number, you put it in parentheses. You put in 1/4 for m, the slope, and you put in 3 for x1. Now to simplify it, minus a negative is the same thing as adding, so you would write this as y plus 2 equals, you can drop that parentheses, 1/4 times x minus 3. That's the final answer for the equation of the line in point-slope form. In order to graph the line, you're going to do 2 steps. Step 1 is to plot the point that they gave you. If you haven't already made your background as a grid, remember you can click at the top of your screen on View and choose Rule Lines here and pick the one that says Grid. So you'll probably want the small grid. Let's draw our coordinate plane. Label our x-axis and our y-axis. Then plot x is 3, so we'll go to x is 3, y is negative 2. Where do those meet? That's this point right here. After you plot the point, step 2 is to use the slope to find another point. with the slope 1/4, the numerator will tell you the change in y. So this is saying up 1 since it's positive. The denominator tells you the change in x. So this is saying to go right 4. Remember, we always go to the right. The positive or negative tells us whether to go up or down. So from that point that you just plotted, now you're going to go up 1, and then you're going to go right 4. 1, 2, 3, 4 to get you over on another point. You can double check to make sure it looks right because the line should be going up as a positive slope. 2 points is enough to make a line, so you could go ahead and connect those. Let's say you wanted to get more points, though, on your line. You could also continue the same pattern of going up 1, right 4. So you could repeat from this point on 7, negative 1. You could go up 1, right 4 again. So your x-intercept would have to be 11, 0. You could follow the same pattern over and over as many times as you wanted. If you wanted to move to the left, let's say you wanted to figure out what the y-intercept was, you would have to go down and left. So you would go down 1, left 4, place your point on negative 1, negative 3, and you can tell that this one doesn't have a y-intercept that's an integer. The y-intercept is something between negative 2 and negative 3, but we can't tell exactly what it is based on the graph. So to review on the graph, you're going to plot the point that you started out being given. In this case, we were given 3, negative 2, so we plotted 3, negative 2 first on the graph. Then we used the slope 1/4 to find another point. So we went up 1, right 4, and found this point at 7, negative 1. 2 points is plenty. You could draw the line from that, or you could repeat the pattern in both directions if you wanted to get more points. Now go ahead and pause the video and see if you can try the practice problem. And here's the right answer for this one. The equation would be y minus 2 equals negative 3 times the quantity x plus 2. And the graph would look like this. Finally, let's try a challenge problem together. It says write 2 linear equations in point-slope form for the points in the table. Show that the equations are the same by converting them to slope-intercept form and graph the line. So we're going to write these equations in point-slope form. So we can pick any 2 points and figure out the slope. We've said that in chapter 3, that in order to find the slope, we need to find the change in y divided by the change in x. So let's figure out between these 2 points. Actually, let's use these 2 because I like how the numbers are positive and they look easier to work with than the negatives. So first, the change in y, we're adding 5. So the change in y is positive 5. Change in x, we're going up 3. We're adding 3. So our change in x is 3. 5 divided by 3 can't simplify down to an integer, and it doesn't reduce at all. So our slope is simply 5/3. Now, in order to write an equation, we can pick any point in the graph. So let's just say we wanted to pick this point, 2, 0. 2 is the x, 0 is the y. So we'll use x1 is 2, y1 is 0. Use your formula for point-slope form of the linear equation. Substitute in 0 for y1, 5/3 for your slope, and 2 for x1. Y minus 0 makes just y. So you can simplify this to y equals 5/3 times the quantity x minus 2. That's one equation to represent the line for this table. They asked us to write two different equations though. So now let's pick another point. Let's say we wanted to use this point, 5, 5. So we'll do the same thing, now using the point 5, 5. You could have picked any of the points in the table. We just decided to use these two because I like how they were positive numbers and they looked easier to work with. Write down the formula for point-slope form of the linear equation. Substitute in 5 for y1, 5/3 for the slope, and 5 for x1. This one doesn't simplify at all. This is the equation. The other part of the question said to show that the equations are the same by converting them to slope-intercept form. Remember, the formula for slope-intercept form is y equals mx plus b. You should know how to convert these based on what we did in Chapter 3. You would have to distribute the slope. On the pink equation, 5/3 times x is 5/3 x, and 5/3 times -2, it's a positive times a negative, so I know it's going to be a negative. And then you could treat it as 2 over 1, so you get 5 times 2 is 10, 3 times 1 is 3. Similarly, for the blue equation, 5/3 times x makes 5/3 x. A positive times a negative makes a negative. If you want to treat this as 5 over 1, so you can do 5 times 5 is 25. 3 times 1 is 3 in the denominator. Now this one's not quite finished yet because y isn't by itself. So the final step to get this one in slope-intercept form is to add 5 to both sides. Y minus 5 plus 5 makes y plus 0. But y plus 0 is just y, so now y is by itself. Bring down your 5/3 x, then combine the like terms 25 over 3 plus 5. In order to add together fractions, we have to get a common denominator. So let's go off to the side and figure out what's negative 25 over 3 plus 5 over 1. The common denominator would be a 3. In order to get the common denominator 3, the first fraction is already good, but the second fraction, we would have to multiply by our sneaky 1, 3 over 3. Remember, you can only multiply by 1 because that doesn't change the number's value. For example, 15 over 3 has the same value as 5 over 1. So now when you add it together, negative 25 plus 15 gets you, negative 10 over the common denominator 3. So we got the exact same thing, y equals 5/3 x minus 10 over 3. Once you put it in slope-intercept form, the equations will be the exact same. In order to graph the line, we'll make our coordinate plane. We could start at the point that we used first, 2, 0. So x is 2, y is 0. It's actually the x-intercept. Then, based on the slope of 5 over 3, that tells me that the change in y is 5, the change in x is 3. So I'm going to go up 5 and right 3. Then I could connect my points and notice that that lands on the point, the next one, 5, 5. You could also have followed the same pattern to the left by going left 5, down 5, left 3. So we'll go down 1, 2, 3, 4, 5, left 1, 2, 3, and place another point. Notice that lands on the previous point in the table, negative 1, negative 5. You only really need 2 points to graph the line though. So once you have 2 of the points plotted, you could graph it. And if you continued following the same pattern, you would end up finding that each of these points lands on the line. So what I want you to know from this is that two equations can look different in slope-intercept form. They can look different in point-slope form, but they're the same when you put them in slope-intercept form.